Thank you for having me here. I'm Asdrúbal Pichardo. I'm the CEO of FactoryPal, which is a software as a service startup. And I will be sharing with you how we are applying artificial intelligence to improve and boost the performance in the tissue production. And I would like to start a bit talking about trends and challenges, opportunities and challenges. And the opportunities from the point of view of applying technology or digital solutions to help you to address certain challenges that you have. On one side, I mean, no industry, including tissue and paper, can afford to ignore the new trends and the new technology. I think like data-driven world, so really applying data to help you to make the right decisions and to have a direct impact to the performance and the production. We will see how to apply machine learning, artificial intelligence, cloud computing, I mean, which really having solution in the cloud where you can innovate very fast and apply and profit for new innovations. Internet of Things, so collecting data, whatever that is, from different machines, as we will see, and of course virtual reality. And the industry, we look at tissue, you have of course the challenges from the market. I mean, last year, COVID gave some of you a boost on the consumer part, so really the demand for toilet paper. But on the other side, some of you were particularly hit on the away from home business, right? So that's went down. And not to mention this year the challenges with the price increases with the raw material and logistics constraints from the producers in China. And then, of course, you also have the pain points which apply to the actual tissue production process. And I hope some of you can relate to this. So starting with not having enough transparency on how the line and the machine is performing, having different skill sets, skill levels. You have operators with different skill set, and that's of course cost that the machine might be not running at the right settings with the right optimization. There's no feedback loop. There's no visibility on how the parameters play together and how they are affecting output and performance. So these are typical challenges that we know from the tissue production, and there are options to address those. Before I get to the solution itself, just to remind you and just to refresh, I mean, the OEE, the overall equipment effectiveness in the industry is not as high as we will wish, right? I mean, on the right side, we have the dream 100%, which obviously is not easy to achieve or impossible because you always have changeovers, you have maintenance, you have machine cleaning, and so on. But in the middle, if you try to achieve at least 75%, that's really a very nice place to be. And independent where you start with a baseline of 40% or 50%, I mean, I've been now working on this, and I've seen 50, 40, and I'm talking about the tissue converting process. If you look at the paper making process, probably is a bit higher. But it doesn't matter if it's 40 or 50, definitely there's a potential to get you to the 70%. I mean, you have this unplanned downtime, you have reduced speed, the line might not be running at the right speed, and that, of course, decreases the performance. So this is really the sweet spot that can be really addressed by applying the right technology, in our case, artificial intelligence and machine learning algorithms. Yeah. And by the way, this was a study that we did together with Boston Consulting Group last year. So now let's see how this works. What is the idea behind? It's pretty straightforward. We take the data from the lines, from the actual production data, and you will see in another chart all the type of data we use. But basically, we connect to the shop floor, to the lines, and we get the data. And this data is brought up to the cloud, and there we have our solution, an algorithm that is automatically determining the optimal settings, so the optimal center lines for the lines, for the production lines. And this is pushed real time to the operator in the shop floor by means of a mobile app. And this happens all the time. And when the operator applies this recommendation from our machine learning algorithm, then they will experience a significant increase on the OEE. We are seeing up to 30%, so this can be significant. We also see a significant reduction of the downtimes of the machine. I mean, the planned downtimes are planned, so nothing much that can be done, but reducing the unplanned downtimes is huge, and we are already seeing up to 50% with our existing customers. And this is actually in essence, the solution, and I will show you how that works. So we are talking about hybrid intelligence because actually the algorithm learns from the knowledge from the operator. So the machine learning algorithm learns what has worked well in the past. So it learns from the experience of the operators and improve that and push that back. Of course, big data and IoT, Internet of Things, so really collecting data from the machine directly. There are many ways to do that. And it's also an augmenting companion because we put a mobile device in the hands of the operator for the first time. So it becomes a tool in their normal daily workflow. So it becomes an augmenting companion. There are different functionality. Just very quickly, I just want to highlight on the right, we have the operator. On the left side, we have the process engineer. On the right side, the main feature for the operator is the guidance. So really, you can think about like Google Maps that helps you to drive from A to B. So this solution is really guiding you, the operator, and showing what to do in terms of setting the machine and running the machine. And of course, because we are collecting the data real time, you can also see the shift KPIs, you can see the current work order, so which product is being produced with which specs. It's also something that the operators appreciate because now maybe it's manual. They can now have it for the first time electronically. And the process engineer, they have a view, they have an application running on a browser that show them this recommendation we are doing and also managing the central lines from the algorithm. There are other features, but I will skip that just to move on. This is just now showing some screenshots of the mobile app. You can see here a line. The line can be, we are vendor agnostic, so the solution works independent of which vendor is being used. So this is a typical converting line where you have the different machine parts. So you have the rewinder, the unwinder, the embosser, the tail sealer, and then after you have the packager. And you can see here actually a screenshot where the solution is recommending changes. And this is very specific. So we are telling, for example, here, the operator change the pressure dance roll from 3.3 bar to 3.5 bar. So this is very specific. And the operator normally accept that recommendation. We will know that the operator accepted because we are reading and seeing what's being done on the HMI, on the human machine interface from the machine. You can see the picture there on the right. But if the operator rejects it, there might be good reason why she or he does not agree. We want to capture why it's being rejected. So, and this information also flows into the algorithm to improve with the time. And you can see here the recommendations are specific to the different machines, so the rewinder, the unwinder. We also not only capturing and recommending electrical parameters, we also can recommend mechanical settings. It's also important in the converting process. For example, here we are saying on the embosser to change from to 43 millimeter, the embosser roll and nip. And on the right, you see some screenshots showing the KPIs, what is the actual status of the production based on the work order. And here on the left, you can see just the welcome screen, so the home screen. And you can see here, we covered the line end to end. So it's not only the converting part, the rewinder, we also can tackle the packaging and the palletizing. So the recommendation on the parameters are also related to that. Obviously, also there's a lot of dashboards and visualization, analytics. So when you collect all this data, you can really generate a lot of insights based on the data. So what are the top parameters that are being changed by the operator at the OE bridge? So where you losing time, where your speed is decreasing the speed, and so on, and also some heat maps. So just to give you a flavor of how the machine learning, or how the magic works, I refer to this to our secret sauce. So really, we collect all possible parameters, and there's technology to do that today, so it's not new. The more parameters we get, the better. And then in the case of a tissue converting machine, it can be anything between 200, 300, 400 parameters. And then our data scientists have already determined which are the ones that have an influence. So which are the ones that are an impact to move the needle in the right direction. In this case, we are talking about between 30 and 40 parameters. So the recommendation of the algorithm are around those 30, 40 parameters. The algorithm is actually predicting a future OEE. So the algorithm in 3 hours window determine what will be the OEE in the next 3 hours if I apply these settings. And this happens all the time. And as you can see here in the curve, what we are predicting is actually what is coming out, which is another proof that the algorithm works well. And on the right, you see this feedback process I mentioned before. So when a parameter recommendation is rejected by the operator, we capture the reason why, and this flows into as a learning for the algorithm. And this happens automatically. So you can imagine if you have a production run of 24 hours for a specific product, or 2 days, we know exactly, and every hour or every 30 minutes, there's a recommendation coming to the operator. And you can think also, you have this app on the iPhone or in an Android device, and you get a notification and you react on that notification. This high-level landscape is cloud-based, so we capture the data. So we put in the factory of the customer a small box, small computer, which actually capturing the data every second, every minute, and this data comes into the cloud. In our case, we are using Amazon Web Services, but it's actually not directly relevant for the customer. And then from the cloud, we provision and serve our applications. I mentioned the mobile app, but also there's a back office app for the process engineers, for the shift supervisor. In addition, we have this link here. You can see we also need data from your ERP, MES system. Why? Because our center lines, our recommendations are specific, not only to the line, but also specific to the product. We need to know exactly what's going to be produced there in the next 24 hours. So things like product specifications and the work order is relevant information. We also need to capture that. This can be every 10 minutes or every half an hour. At the beginning of our project, it's probably can be exchanged via email, but if we are now in a running implementation, it can be automated. And all these only work if we are providing consulting. So we have shop floor consultants that take hands with the customers and really are there to implement and make sure that the operators and the process engineers understand and adopt the solution. Without that, we wouldn't be successful. This showing you now different sources of data, obviously machine data, so the 400 plus parameters I mentioned. So read it directly from the PLC, the set points, measure values, ERP system, I mentioned why that's important for the product specs and the work orders. And there are other sources that are relevant for us. For example, mechanical settings, things like temperature, vibration level can also be relevant. The quality of the motor roll, depending where you are, we call it motor roll or parent reel. It's also well known that the quality of the motor roll has an impact on the converting process. So things like the humidity and the grammage, the weight of the roll have an impact. So also that is relevant information to improve the recommendation of the algorithm, and even taking some visual inspection. So if the customer has some visual, capturing data visually can also be fed into the algorithm. So it's continuously evolving. Security is a big issue when we talk about the cloud, and we take this very seriously. So obviously there's a lot of features being provided by the cloud provider, in this case Amazon, but also making sure that the gateway doesn't have an incoming connection into your system, it's only outgoing, and strong authentication, encryption. We are part of a bigger group and enjoyed things from the Corba group, for example, the Cyber Defense Center. So whatever we are getting from Amazon is complemented by this contact monitoring from the Cyber Defense Center. So a lot of things in place to make sure that the customer gets his data well protected and the required trust. This is, if we don't take this serious, we want to be in business. That's applied to any cloud software as a service provider. Just some evidence on whether this is working or not. I mean, this is not science fiction. We have started doing this more than 1.5 years ago. We have now several customers in Europe and also very soon also in North America. And this is just an example of one customer where we have been constantly increasing the OEE by 20–30%. We measure that also in terms of percentage points. And you can see here in 5 months on the row, 4, 5, even 8, close to 9. So this is significant if you put the numbers. What does it mean for a tissue manufacturer to increase the OEE by 3, 4, 5 percentage points? And on the right, you see the also evidence on how the unplanned machine stops, unplanned downtime, so went down by more than 50%. And this, here in this particular case, the baseline we are comparing against is about 44%, which is pretty standard in Europe, as I've seen. And this is a relative complex production, so we are not talking here about one product. So in this line, this customer is producing more than 9 products, mainly toilet paper. There's also a bit of kitchen rolls here, but it's mainly toilet paper in this particular case. And it's very important, the adoption rate of the center line. So we can only claim our solution is working if the operators are accepting our recommendation. So we also track that. It's a measure of the success and the impact. So we want to be above 75%. In this case, we have been above 80%. So the operators are really believing and implementing our recommendations. Some good feedback we get from our end users that they like it, waiting when this can be rolled out to other lines. Also the workers' council lead, so people concerned about aging workforce or people retiring and being afraid they will lose knowledge. Well, with this solution, that's no longer the case because actually the knowledge is in the app. So even someone new and younger generation, they can really be brought up to speed pretty quickly and start operating the machine from day one because the algorithm is telling them what to change, what to set. And with this, I'm at the end of my presentation. We are here at the booth 16, which also Corba. So if you have any, if you want to see a demo, if you want more details, please come visit us. We will be glad to answer any questions. I don't know if we have time for one or two questions, if there are. Otherwise, just come to the booth.
Yeah, we are really efficient. We are faster than the converting machine today, and we are even in advance in our agenda. So if there is any question from the floor? No, today everybody are quite shy. I have one. I always ask this question when it's about IoT and Industry 4.0. My feeling is that what you propose is very invasive for a company in all levels of the company, up to the operator and so on. Which is the acceptance? And do you see a generation gap in that? Or this is already an issue of the past and now it's already not anymore a problem?
A good question. Different aspects. So, of course, generation gap, you always will experience the older generation and the newer generation, so the digital affinity. And we actually see that with our customers, so the younger operators helping the older operators how to use the app. But it's improving. So people are when they see the benefit and seeing how the application is helping them to achieve their goals, there's a very high acceptance. And doesn't suffice that someone at the top is deciding to implement this. We really need to get the buy-in also from the plant managers and from the plant people. And this is part of our consulting approach, where we are there with our shop floor consultants to hold hands and make this a reality.
Thank you.
Well, thank you.